All right, so we are on chapter 3, section 2. We are in search of an octet, right? So that's what we want. We want to get an octet. How do we get an octet? Is that we either gain, lose, or share electrons. And so we're going to talk about gaining and losing electrons today. So you need to remember your definition of an atom, right? We know that our number of protons is equal to our number of electrons. And if this is true, then what can we say about that atom? Well, we can say that that atom is electrically neutral. So it has no overall charge because its positive charges equal its negative charges. It is neutral. So that's our definition of a neutral atom. But not all atoms out there are neutral, right? If they gain or lose, they're going to have a charge. And so that's what we're going to talk about today, is that when we have particles that have unequal numbers of protons and electrons, then they're going to have a net charge. And that net charge can be either positive or it can be negative. If the charge is negative, we call it an anion. If it's positive, we call it a cation. So how do you become a cation or an anion? Well, if you become an anion, that means that you have gained electrons. So let's look at an example. Let's look at chlorine. Chlorine, if you look on the periodic table, is number 17, right? That's what you would see in the box. And how would we find out our number of valence electrons? Well, we know that this is in group 7A. So if you look in that column, that 7A column, you're going to see that that's chlorine. So we know we have 7 valence electrons. So if chlorine has 7 valence electrons, right, what does it want to do? It wants that octet. How's it going to get an octet? It could do one of two things. It could gain 1 valence electron to get to that octet, or it could lose 7. Because if it lost 7, then when you're looking at how many valence electrons, you would look at that next lower principal energy level and you would see that it's full. And so it would have an octet. But losing 7 valence electrons is hard. That takes a lot of energy. It's much easier just to gain 1 and then you have that complete octet. So what chlorine is going to do is it's going to gain 1 valence electron. So if it does that, let's put it over here. Let's say we started out with this chlorine atom, right? And we said it had 17 protons and it has 17 electrons. But then we said something happened, right? It's going to gain 1. So we're going to put another negatively charged electron and we're going to get a chlorine ion. So this chlorine ion still has 17 protons because it's still chlorine, but it has 18 electrons. So now we have 1 more negative charge than positive charge. So overall, all this put together has a charge of -1. And so we have to show that. When we show the ion, we write the symbol and then we write the charge. So this is our ion, this is our atom. You can tell that they have the same symbol, the same Cl, but the ion actually has the charge, and so you have to list that. So if chlorine does that and it gets a complete octet, the question is then, what does its electron configuration look like? So if I go to the periodic table, and I find chlorine, where's chlorine? Here we go. Here's chlorine. Chlorine started out and it had 17 protons and 17 electrons. It is going to gain 1 electron. And so chlorine, the chlorine ion, right? You already saw this. The chlorine ion is now going to look, in terms of electrons, like another element on the periodic table. What element is it going to look like? Well, it's going to look like it's gained 1 electron. Right? We had 17, now we have 18. So the chlorine ion has the same electron configuration as argon. And remember we said argon is a noble gas. It's in that last column. So it's super stable because it has a complete octet. Well, the chlorine ion now also has a complete octet. So what do we say? We say that the chlorine ion, that's another way to write ion, is just to put the negative sign, right, is isoelectric to argon. Iso means same, and electric means electrons. So it has the same electrons as argon. And that makes sense, right? The chlorine atom wants to become stable. How does it become stable? It gets a complete octet. Now, what element already has a complete octet in the same configuration? That's argon. So that's what we say. It's isoelectric. It's a fancy way to say it. Okay. So that is an example of an anion. An anion is negative. Let's do the same thing and let's look at a cation, right? So cations can also become isoelectric. So if we look, for example, at sodium. Sodium on the periodic table, if you look, is in group 1A. So it's in group 1A, right? And it is element 11. So it has 11 protons and 11 electrons. How many of those electrons are valence electrons? Well, if it's in group 1A, it has 1 valence electron. Is it going to gain 7 electrons in order to get to an octet? No way. That's too hard. It takes too much energy to gain 7 electrons. So the easier thing for sodium to do is to lose 1 valence electron to get to our octet, because we want an octet, right? So what did we start out with? We started out with the sodium atom. This is the atom. And we had 11 protons and we had 11 electrons. So when sodium loses 1 electron, we're going to subtract 1 electron. What's going to happen? We're going to have 11 protons, but instead of having 11 electrons, now I'm only going to have 10 electrons. Okay, so what does that do for my overall charge? I have 1 more proton than electron, so I'm a +1. So we just put the little plus sign. If it's a 1, it's understood as being there. So this is the ion, this is the atom, and that should not be a capital A. Come on, lowercase a, okay? So sodium atom versus sodium ion. It's just a different number of electrons, right? Okay, so let's go and see, what is it isoelectric to? Let's erase this stuff, right? I want to erase all this. All right, so I use this. All right, here's sodium right here. It started out with 11 protons and 11 electrons. I want to know, what is it isoelectric to? In order to do that, look at the element that has 1 less electron than sodium. So if sodium had 11, and it became an ion, and now it has 10 electrons, what other element has 10 electrons? Neon. Neon has 10 electrons. So sodium ion is isoelectric to neon. So always just look at this number at the top and then go 1 less or go 1 more. And that's number of electrons. I know it's also number of protons, but in this case, we're not really worried about the protons, we're worried about the electrons. All right, so if you look at the periodic table, it's very easy to identify what ions form. If you're in the metals, so groups 1, 2, and 3A, these form cations. And the cations are going to form with a charge equal to the group number. Let's see if that makes sense. So, I can erase, right? Okay, so if we are in, let's say group 1A, let's say I'm lithium. What's going to happen to lithium? I have 1 valence electron. I want to lose that 1 valence electron, lose 1 electron. If you lose 1 electron, you're going to be a +1. What if you're beryllium? Beryllium has 2 valence electrons because it's in group 2. So beryllium's right here. If I have 2 valence electrons, is it easier to lose 2 or to gain 6 to get to 8? Well, I'm going to lose 2. So if I lose 2 electrons, now I'm going to have 2 more protons and electrons, and I'll be a +2. If I am boron, right? Boron can, really aluminum's a better example because it's a metal. So aluminum. Aluminum has 3 valence electrons. If aluminum has 3 electrons, what's aluminum going to want to do? It's going to want to lose 3 or gain 5. Easier to lose 3. So we're going to lose 3 valence electrons, and we're going to have a charge of +3. Okay? So we know group 1A has a charge of +1. Group 2A has a charge of +2. 3A, charge of +3. Now, those are our cations. When we start to form anions, those are going to be in a different group. So groups 5A, 6A, and 7A all form anions with a charge equal to 8 minus the group number. Let's see what that means. So, let me erase this stuff. All right. So, if I am in group, let's say 5A, if I am nitrogen, nitrogen is in 5A, so it has 5 valence electrons. I have 2 possibilities, right? I could gain 3 electrons and I'll get to 8, or I can lose 5 electrons to get to 8. It takes so much more energy to lose 5 electrons than to gain 3. Remember, we want to kind of do the least amount of effort to get what we want. And so that's what these atoms are doing. So this atom's going to gain 3 electrons. If you have 3 more electrons than protons, now you have an overall charge of -3. So let me put that over our group, -3. 6A. If you're in group 6A, you have, see if I can do it this way. So 6A, we have how many valence electrons? We have 6 valence electrons. If we have 6 valence electrons in group 6A, either we can gain 2 or we can lose 6. Oh my goodness, that's never going to happen. Never going to happen. So we're going to gain 2 valence electrons. So if you gain 2, now you have a charge of -2. Fluorine. Fluorine's in group 7A. 7A has 7 valence electrons. It's really easy. All I need to do is gain 1. If I gain 1 valence electron, then I'm going to have a charge of -1. So when all 3 of those elements, nitrogen, oxygen, and fluorine, gain electrons, they're all going to now be isoelectric to neon because they now all have 10 valence. They all have 8 valence electrons, just like neon. Okay. All right, so let's go back to our notes. So groups 5A. If you're 5A, what's your charge? Your charge is the group -8. So 5 minus 8 gives you a -3. If you're in 6A, 6 minus 8 gives you a -2. 7A, 7 minus 8 gives you -1. And those are your charges. So be careful with that and make sure you get those anions correct. You have some transition metals, the ones that are in the middle of the periodic table. So the ones in the middle are all these in here. And they can have multiple charges. And so I'm not going to make you remember what they all are. I will give them to you in the cases that you will need them, because sometimes you will need them. So let's go back. All right. So we talked about forming anions. We talked about forming cations. Those are individual atoms that have charges. But sometimes you can have a group of atoms that all have the same charge. So for example, you could have HCO3, and this whole thing, all these atoms together, have a charge of -1. This is called a polyatomic ion. So this is many atoms, and the ion tells you it is charged. So do I have many atoms? Yes. As long as you have more than one, the answer is yes. So we have hydrogen, we have carbon, and we have 3 oxygens. And when all those are put together, they have a charge of -1. And so that charge is for the whole group of atoms. And polyatomic ions are super important in the body, and we'll show you a few examples. So you should use your periodic table, your normal periodic table, the one that I keep going back to. But this is just kind of a nice visual look at all the different elements and what ions they commonly form. And so if you look, right, everybody who's, let's say, in group 7A, they're all -1. Everybody in group 5A, they're -3, right? If you look in group 2A, everybody's a +2. But if you look at these transition metals, so these guys right in here, what you can see is some of them can form different ions. And so you won't have to memorize them, but you just have to know that that does happen. So these are some other common polyatomic ions, and we use them. They're actually in our bodies. Our bodies use them. We use them in industry. We use them in drug treatments, right? All kinds of stuff. And so ions are very, very important. And so if you look at like NH4, this is an example, ammonium, this is a polyatomic ion. So the nitrogen, the 4 hydrogens together all have a charge of +1, right? So it's the entire compound there that has a charge. It's not just one atom. So be careful about that. So these are all kinds of different ones. And if you have to use them, I'll provide you with a table. You do not have to memorize them. Now, when we talk about them, we have to name them specifically, because if I just tell you an atom name, then I'm talking about the neutral atom. So we need to be specific. And if it's an ion, say it's an ion. So if it's a metal ion, all we do is we add the word ion. So if it's sodium, that's the sodium ion. So where are metals? These are the blue ones. So if you had potassium, potassium ion, rubidium, that's the rubidium ion. Cesium, cesium ion. Really easy. Transition metals. Transition metals, we say the name of the atom, and then we use parentheses and Roman numerals to tell the charge. So for example, let's look at Fe, iron. We would say it would be the iron 2 ion, or it would be the iron 3 ion. So it's those Roman numerals. So you do need to know your Roman numerals. Okay. And then when we talk about our nonmetals, we're going to change the end or the suffix of the word to IDE. So if we come over here, we have the fluoride ion. We have the chloride ion. We have the bromide ion. Anything that's a nonmetal, so the yellow, is going to end in IDE. Super important, IDE. Okay, so let's go back, and we have one more to talk about, and that is our polyatomic ions. Polyatomic ions are going to end in one of two things, ATE or ITE, either one. Either one's, and it depends on the number of oxygens that are in there. The ITE end is usually when you have fewer oxygen ions, and ATE is when you have more oxygen ions. So you have to know that rule, but you don't have to memorize them. You're going to look in a table, right? So I'll give you an example, right? I'll tell you if you have SO4 2-, that is going to be sulfate, ATE. Remember, ATE is more oxygens. So if I drop my number of oxygens and I end up with SO3 2-, what I'm going to end up is sulfite. So notice what ended was the ate and the ite. Now be careful, Because what if I have this sulfur ion and it's a non-metal? So if I want to say this ion, S2 minus, how am I going to name that? I'm going to call that the sulf, LF, but I'm going to end it in ide, sulfide. So be careful. Sulfide, sulfate, and sulfite are 3 different things. That's kind of the more tricky one. But what if you just had a neutral atom? You would call this sulfur, right? So be careful with that. You need to recognize the endings and be able to say, oh, is that an anion or is that a polyatomic ion? So you have to be able to tell that. All right, let's go do some problems. We're gonna go to here, 3.2, in search of an octet. Okay, what is the difference between an atom and its cation? The difference is going to be the charge, right? And how did you get the difference in charge? Is that you are going to gain or lose electrons. If this is a cation, how do we know? How do we know what's going to happen, right? If it's a metal ion, we start with the atom, right? And its number of protons is equal to its number of electrons. But if it's a metal, and remember that's the blue on the left side of the periodic table, right? Our metals are here. These are our main group metals, but these are all transition metals. So they're all metals, okay? So what's gonna happen is that they are going to, so this is metal atoms. Now they're going to gain, or are they gonna lose? What are they gonna do? These are going to lose electrons to get an octet. So if they're gonna lose electrons, now they're gonna have more protons than electrons. And so they're gonna have a net positive charge, okay? How are the names of a non-metal atom and its anion different? Okay, well, a non-metal, this is the yellow. And so remember, an anion tells you that it's negative. So how is it different? So if you're going to be an atom, you're just going to say the element name. But if you are an anion, what you're going to do is you're going to be the element and you're going to end it in IDE. So fluoride, sulfide, anything that ends in IDE. Okay. Provide the charge when an ion is formed from each of the following. Calcium. What you should do is you should go to your periodic table. I'm not going to do every one, but go to your periodic table. Calcium. What group is calcium in? Group 2A. What's my charge? +2. So when you get an exam, you're going to have a blank periodic table. So I don't suggest that you write on, like maybe you can have one periodic table that you write on and one periodic table that you keep clean. That way you can practice with the clean one. But then if you want to go in and you want to write your charges, +1, +2, +3, -1, -2, -3, if you want to have something like that so that you can double check yourself, that's fine. But don't use the one that you've written all over to do like homework and stuff like that, because you want to practice kind of like it would be on an exam. Okay, so calcium, we said calcium was in group 2, so that is going to have a +2 charge. Oxygen, oxygen is in group, go look, group 6, and I should put an A, 6A. So remember, how do you do this? You do 6 minus 8 is going to give you a -2. So this is going to be a -2. Nitrogen is in group 5A or group 15. So what's going to happen is you're going to do 5 minus 8 will give you -3. Okay, potassium. Potassium is in group 1A. And remember, you don't have to subtract for those 1, 2, and 3. And that's a +1. Okay. All right. How many protons and electrons are present in the following atoms? Let's make a little table. P plus, E minus, right? Okay, so magnesium, oxygen, chlorine, and copper. All right. I'm gonna try to zoom in, make this a little easier to see. Okay, magnesium. How many protons are present? So what are you gonna do? You're gonna go to your periodic table. We're gonna find magnesium. Here's magnesium. It is element number 12. So that number 12 is telling you that you have 12 protons and 12 electrons, right? But that's the neutral atom. What is magnesium going to do? Magnesium is going to lose 2 electrons. So instead of having 12, I'm now only going to have 10. And that gives me my overall charge of +2 because I have 2 more protons and electrons. So let's go down and see what we had to do. So magnesium 2+, right? So our initial atom, we'll put it over here. Our atom, proton, electron. We'll keep it straight in our minds, right? We had 12 and 12. But what happens here is we have a +2. That tells us that we're getting rid of some electrons. So we still have 12 protons, but we're getting rid of 2 electrons. I know it's a plus sign, and that gets you sometimes, but remember that means the 2+ means you have 2 more protons and electrons. So it must mean that you have 10 electrons. O2-, we know that we have 8 protons. If you go look on the periodic table, go practice. And you have 8 electrons. Now it has a charge of -2. That means you have 2 more electrons than protons. Protons don't change, and you're going to get 10 more. You're going to get 2 more to get a total of 10. All right, chlorine, 17 protons, 17 electrons. Chlorine's a -1. Your protons aren't going to change, but you're going to gain an electron, so you have 18. That's what the -1 says. You gained an electron. Copper 2+. So we have 29 protons. We start with 29 electrons. What does the 2+ mean? It means we had 2 more protons than electrons. So we're going to have 29. We need to have 2 more protons than electrons. So 29, 28, 27. Okay. All right, let's see. Okay, naming. Name the ions in problem 3.13, but I went ahead and was super nice and reposted those 3.13, right? The ones that we just did. So how are we going to name them? Remember our rules. Let me put the rules over here. If it's a metal, right? We're going to a metal, or the other way you could think about that is if it turns into a cation, right? Either way, you're going to put the name and then you're going to add ion. What if it is a non-metal and it is an anion? What are you going to do? You're going to begin the name. Oops, sorry, y'all. Okay, you're going to begin the name. Let me clear that. And then you're going to end it in IDE. So that's our rules. Okay, magnesium 2+, that's a cation. So we're going to just put the name magnesium, and then we're going to say ion. Super easy. I like these. Now, B, we have oxygen with a 2+ charge. So this would be oxide. Usually we put the first syllable of an element and then we end it in IDE. But as long as you put the IDE, it's okay. So the next one's also going to end in IDE because it's negative. So this is chlor, CHLOR-ide, chloride. Copper. Now be careful. Where do you find copper on the periodic table? Go look. You should have found it in the transition metals. And so we don't know what ion it's going to be, what charge it's going to be. So when we say the name, we need to say which one we're referring to. So this is copper 2 ion. Okay, so just be careful about that. All right, let's see. Give the name and symbol of the ion with the following number of protons and electrons. And it looks like I missed one. It looks like I missed 3.17. I'll go back and do that one in class. I'll figure out what it was. All right. Give the name and symbol of the ion with the number of protons and electrons. So if you want to know which element it is, you're going to go look at protons. So protons, if you have 12 protons, go look. You should end up with magnesium. Now, it doesn't have the same number of protons as electrons. It has 2 more protons and electrons, so it's going to be Mg2+. So how do we say that? We already did this one. Magnesium ion. And that is Mg2+. Protons, 26. 26 is going to be iron. So what's my charge? Well, I have 3 more protons and electrons, so I'm going to be a 3+. So this is going to be iron, but be careful because iron is a transition metal, and so we need to say it's iron 3 ion, and it is Fe 3+. Okay? All right, name the following ions. What you should see is, oh my goodness, I have more than one atom. That's a polyatomic ion. So what I want you to do is I want you to go back to your notes, and inside of your notes, you have all of the polyatomic ions present. So I think, what did we say? That one was NH4. So that was what we needed to look for, NH4. And here we have NH4. So what is it called? It is called ammonium. Ammonium, right? C2H3O-. Go look for it on the table. Take a second, go look for it. I'm not going to find it for you. You need to find it. It is called acetate. Acetate. Cn-. All you have to do is go find it on the table. This one is called cyanide. A-N-I-D-E, cyanide. Now cyanide is the only polyatomic ion that is going to end in, guess what? IDE. I don't know why they do that. Just to mess with us, right? So cyanide is a polyatomic ion, but it ends in IDE. Be careful. Just be careful with that one. Okay. And I think that's it. Yay for section 2. If I could close this. I hid my meeting controls and now I can't get to them. Oh, that's so funny. Oh, there they are. Okay, bye y'all.